In this video we're talking about ellipses and calculus. So we've already covered ellipses back in pre-calculus. This time we're going to look at them through a calculus lens. We're going to start with writing down the standard equations of an ellipse. Alright, so we have two types of ellipses. We have the ones where the major axis is on the horizontal, meaning they're oval shaped going this way, so they're longer on the horizontal axes, and then we have the vertical ones that are longer on the vertical axis. So for our first problem, we're asked to find the center, vertices, and focus of the given ellipse. Now what we're going to do first here, if you remember back from pre-calc, is we're going to rearrange this. Put all the x's together, put all the y's together, banish the single number to the other side. Over here we are also going to have to factor out a 4. And then we're going to be completing the square. So half of -2 is -1, squared is 1, so we're adding a 1 here. And over here, half of 4 is 2, squared is 4. When we're adding to this side, we also have to add to this side. That 1 right here gets multiplied by the 4 before we add it to the other side. And that 4 we just add to the other side as is because there's just a 1 in front of here. Alright, next we will factor. X squared minus 2x plus 1 turns into x minus 1 squared. Y squared plus 4y plus 4 turns into y plus 2 squared, and we're equaling that to 16. Divide everything by 16. We have x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. Now our center, still h comma k, so 1 comma -2. And actually write that over here because we never talked about the formulas in the box. Let's see if we still remember these from pre-calc. So our centers, hk, our vertices. This one right here is a major axis is vertical, so we have a vertical ellipse. So that means our vertices are h comma k plus or minus a, and our foci are h comma k plus or minus c. So that means for our vertices, we have to figure out what a is. Now a is the bigger number and the square root of that, so that's 4. B is the smaller number, so that would be 2. And then c we're going to have to find. We had our formula up here, a squared minus b squared. So a squared was 16 minus b squared, which is 4. Gets me 12 for c squared, which means c is the square root of 12, or 2 root 3 if we simplify. Now our vertices, we have h comma k, which is negative 2, plus a, which would be 2, and h comma k, negative 2 minus 4, which gets me to negative 6, and my foci, I have 1 comma negative 2 plus or minus 2 root 3. Alright, moving along, we have the moon orbits the Earth in an elliptical path with the center of Earth at one focus and the major and minor axes of the orbits having lengths of this and that. The major axis being the first one. So that means 2a equals 768,800 and 2b equals 767,640. We're finding the greatest and least distance from Earth's center to the moon's center, which would be our outside two things, which are our oh, hold on, this is a circle. Those are our vertices. Nope, our foci. Right, so we're finding our two foci. It looks like it would be the vertices, but since this is actually it is our vertices that we're finding here. So basically the Earth is at one of the foci. So, and these two are both the major and minor axes of the parabola. So basically our center of the ellipse is somewhere here and the Earth is at one of the foci. So this would be our center, right? So 2a is the major axis, and it looks like this one, since the Earth is on the focus, these two would be the vertices of the major axis. So we need to find a, which is 384,400. B is 3,800 or 383,820. And C, if we find it, is 21,108. So since the Earth is at the focus, the distance from the center to vertex is A, but from the center to the focus, that would be C. So if we're finding the least and the furthest distance, we would be doing A minus C and A plus C. So if we are doing that, we've got 384,400 plus 21,108. So our furthest distance is 405,508, and our closest distance is 363,292, and and those are kilometers. So the Earth is at the focus, center is here. Since the Earth is at the focus, we know that this is our major axis, meaning these two out here are our vertices. The distance from center to vertex is A, so the furthest distance is C plus A, the shortest is C, or A minus C. So then this one right here is our perigee, and this one is our apogee. I am probably saying those two words wrong, but that's what those two things are. Alright, so we have a reflective property of an ellipse. So for this one, we let P be a point on an ellipse. The tangent line to the ellipse at point P makes equal angles with the lines through P and the foci. Next, we got the definition of eccentricity of a parabola. So the eccentricity E of an ellipse is given by the ratio E equals C over A. Alright, so for the next problem here, we want to show that the circumference of an ellipse is this thing right here. So if we have an ellipse, let's call that ellipse, so the circumference is the limit as d approaches A of 4 times 0 to d of the square root of 1 plus y prime squared dx, or 4 times the integral from 0 to 4 of 1 plus y prime, that's an A, squared dx, which in this case looks something like this, where we have a 1 plus b squared x squared over a squared times a squared minus x squared dx. So what I'm going to do here first is so we're doing a bunch of algebraic manipulation to solve this. First of all, we have our eccentricity, that if we square it, we get c squared over a squared, but c squared is also equal to a squared minus b squared over a squared. Now, c is 4a times the integral from 0 to pi over 2 of the square root of 1 minus e squared times the sine of 2 theta d theta, or the sine squared theta. Okay, so when we're starting this here, first of all, we have c is the integral from 4 times the integral from 0 to 2 pi of 1 plus b squared sine squared theta over a squared cosine squared theta times a cosine theta d theta. So I did a trigonometric substitution, which we talked about briefly in Calc, and I said we will never actually have to do that, and surprise! Here we do. So back in calculus, in BC Calc, we said it wouldn't be on the AP test, so you wouldn't have to learn it for BC Calc. It is still not something that I expect you to know at any point. It does appear in this particular problem, however, we don't usually have to worry about it particularly. So I'm going to walk through it here. Again, I replaced some things here. Using a trigonometric substitution, I made the x squared into sine squared, the a squared minus x squared into cosine, multiplied by something back here. So it's a little crazy. What I'm going to do next is just algebra, so I'm going to actually try and get this inside of my root. So when I do that, I end up with the square root of a squared cosine squared theta plus b squared sine squared theta. Next, cosine squared theta is 1 minus sine squared theta, so we're using our handy-dandy trig identities from pre-calc. Next, we're going to simplify a little bit, but while I am simplifying, I am also rearranging this slightly because I end up with a squared minus a squared sine squared theta. So instead of writing it like that, I'm going to right away out of the back two terms factor out a sine squared theta, which from here then actually with the help of this with the help of the top part, gets me to this kind of, because what I can do now is if I divide everything by a squared, first of all I get a 1 over a squared that I can pull out of my root, which just leaves me with an a. And over here I have a squared minus b squared over a squared times sine squared theta, which a squared minus b squared over a squared turns into e. Alright, and we proved that it is the original thing. I am aware that I did not explain the trig substitution in that first step here. I did that on purpose because, again, it is not something that I'm expecting you to know. If that is something you want to know, let me know and I will explain it to you specifically, but it is not something I'm expecting you to be able to replicate on a test. Alright, and the bottom one here, we're using the elliptical integral in the previous example to approximate the circumference, which means we're going to have to find e. Now, the integral that we have, so we have 4a is equal to the integral from 0 to pi over 2 of the square root of 1 minus e squared times the sine squared theta d theta. So we need a and we need e, but for e we also need c. So first of all, let's find a. A is 5. And then c squared is a squared minus b squared, so b is 4. So for e, we get 25 minus 16 over 25, or 9 over 25. So if we plug all of this into our integral, we have 4 times 5 times the integral from 0 to pi over 2 of 1 minus 9 over 25 sine squared theta. And if we approximate that using a calculator, we end up with 28.36. And that is it.